Good day, everybody. How are you all doing? Today, we are going to work on this problem. A manufacturer claimed that at least 95% of the equipment that she supplied to a factory conformed, conformed to specification. An examination of a sample of 200 pieces of equipment revealed that 18 were faulty. Test her claim at significance level of A 0.01 and 0.01. So manufacturer claimed that at least 95% of the equipment that she supplied to the factory conformed to the specifications. Okay, from this we have to make the hypothesis statement. So Shinsei claims, okay, that the null, that the at least 85, at least means minimum is 95%, that conform to the specification. So again, 95%, it's a proportion problem. So in this case, the null hypothesis or the status quo is P at least means greater equal to 0.95. That's your null status quo. Okay, at least. Okay, that's a claim also. Then what will be the alternate hypothesis? Remember, alternate hypothesis does not contain the equal to sign, only the null hypothesis has the equal to sign. Okay, so the alternate is just the opposite. P is less than 0.95. So the way we do hypothesis test is to assume that the null hypothesis is true, and then we look at the evidence to see if the evidence will support the alternate hypothesis. Now the evidence is in terms of examination of 200 pieces of equipment revealed that 81. So 200 pieces, so out of 200 pieces, 18 were faulty. So out of 200 pieces, 200 minus 18 is equal to 182 conformed to the specifications. So if 18 were faulty, the opposite 200 minus 18 conformed to the specifications. Okay. So with this information, we will find the sample proportion. So P hat is, this is read as P hat, is the sample proportion of success. In this case, success is the case of is supplying equipment that meet the requirements, that meet the specifications. So we already know 182 out of 200 meet the specification. So P hat is X over N, where X is number of successes divided by sample size. So in our case, this is 182 meet the specification divided by total number sampled is 200. So P hat is equal to, a quick use of the calculator, 182 divided by 200 is 0.91. Okay. So the question is whether this data that has been collected from the sample is strong enough to support the alternate. If the evidence is not strong enough to support the alternate, then we will support the null hypothesis, then will not support the alternate. So if the evidence is not strong enough, if the evidence collected from the sample is not strong enough to support the null hypothesis, or to support the alternate hypothesis. Alternate hypothesis. Evidence collected from the sample is not, this is the important, not strong enough to support the alternate, then we will not reject the null hypothesis. As I told you at the beginning, that we assume the null hypothesis is true. So we find the test statistic which is to compare p hat to the hypothesized value. Okay, so the formula for the test statistic is a z statistic. How many standard deviation is p hat away from the hypothesized value? Is z is equal to p hat minus p0 divided by square root of p0 times 1 minus p0 over n. What is p0? P0 is the hypothesized value in the null hypothesis. Value in the null hypothesis. Okay. The term in the denominator is the standard error of the mean, is the standard deviation of the sampling distribution. Sampling distribution. Okay. So we can calculate the z and find out how much possible is to get that value. Okay, or what is the probability of getting a test statistic as extreme as z. Okay, so we will use TI-84. Okay, we press the stat button. Okay, and then highlight test on the top row, and then scroll down to 1 proportion z test. As I indicated, we will calculate test statistic, and this is a proportion problem, so 1 proportion z test. So stat, then highlight test on the top row, then scroll down to 1 prop z test. Okay, so in the calculator screen it's asking for p0. So what is your hypothesized value in the null hypothesis? Is 0.95. This is the hypothesized value in the null hypothesis. In the null hypothesis. Okay, so we type 0.95. Then it is asked for x. Remember, x is the number of successes in my sample, which is 182. Okay, so I type for p 0.95, x is 182, and my n is sample size, which is 200. Okay, so type 200 for n. The fourth line is the direction for alternate. Notice here the direction of the alternate is less than. So fourth line is direction of of H alternate hypothesis, which in this case is greater than, is it greater than? No, less than, I think, less than. So we should bring it on less than P0. So not, this is not true, it is less than P0, because this is the direction of alternate hypothesis, which is a left tail test. So bring the cursor on less than P0 and hit enter. This is very important. It tells the calculator what is the direction of the test, which is a left tail test, because the alternate is less than. And then we bring the cursor down on calculate and hit enter. While on calculate, you hit enter only once. So bring it down on calculate and hit enter. Okay, so what are the results? Let's see. Z, this is the test statistic. This is a characteristic of the sample that we have collected, of the sample. Okay, so Z is minus 2.596, and we look at the p-value. P-value is 0.004. This is called the p-value. What does it mean? This value is the probability of getting a test statistic value at least as extreme as what we have calculated, minus 2.596. Okay, now compare the p-value with the level of significance. Compare the p-value with level of significance, which is given to us. Level of significance is in statistics alpha. Okay, what are the values of alpha we have been given? There are two values of level of significance. Okay, one is 0.01, another is 0.05. So case 1, alpha is 0.01. What is the p-value? P is 0.004. So you notice immediately P is less than alpha. Now remember, here the P is the probability of obtaining a test statistic at least as extreme as minus 2.56. This is a p-value, probability value. Okay, not to be confused with population proportion. So P is less than alpha, decision is reject H0. Okay, and what is the conclusion? At alpha is equal to 0.01, there is enough evidence to support the alternate. Support HA, that P is less than 0.95. What does it mean? In plain language, it means the parts she is supplying to the manufacturers do not meet their requirements. Okay, let's do case 2. Case 2, alpha is 0.05, level of significance. Remember, alpha is level of significance. Level of significance is alpha. This is to be read as alpha, level of significance. Again, p-value does not change. P-value still remains at 0.004. Again, we find P is less than alpha. Decision same as before. Decision is reject H0. Same conclusion at alpha equal to 0.05. There is enough evidence to support HA, which is P less than 0.95. That means the parts supplied do not meet the manufacturer's supplied do not meet the requirements. Okay, so if you remember, the problem states that a manufacturer claimed that at least 95% of the equipment that is supplied to the factory conform to specification. At least means her claim is the null hypothesis is greater equal to. This is greater equal to is at least, because the lowest value is 0.95 and anything above that. Equal to sign always with the with the null hypothesis. If that is greater equal to, the alternate is the opposite direction is less than. And we found out there is enough evidence to support the alternate. That means the part she is supplying is not meeting the requirements, because we are supporting the alternate hypothesis at both levels of significance. I'll stop here today. I wanted to give you a tip. The tip is to realize that at least means greater equal to, and equal to sign is always with the null hypothesis. If the null hypothesis contains greater equal to, alternate hypothesis direction of the sign will be opposite to greater than, which is less than. Alternate never contains the equal to sign. Okay, and she collected a sample of 200, out of which 18 were faulty. So how many pieces were not faulty is 182. So what is the sample proportion of success? Is number of successes divided by sample size, which is 182 by 200, 0.91. Then we will compare this 0.91 to the hypothesized value, that is the value in the null hypothesis of 0.95, and divided by the standard deviation of the sampling distribution. This Z means how many standard deviation you are away from the mean or away from the hypothesized value. And this being negative means you're on the left side of the mean. Okay, and you look for a p-value for that test statistic. What is a p-value? That is the probability of getting a test statistic at least as extreme as what you have calculated, which in this case was minus 2.596. Now compare that p-value, probability value, to alpha. If p-value is less than alpha, which is true in both the cases, then we reject H0. So if we reject H0, the conclusion is to support the alternate hypothesis. So I stop here today. If you have any question, comment, please do not hesitate to write me on note. If you like this video, please give me a thumbs up. That really motivates me. I really appreciate that. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button and hit on the bell button, which tells the YouTube to notify you every time I upload a new video, which I do quite often. And please subscribe to my channel, because I've solved all kinds of problems just for you. Thanks for watching, and please do not forget to watch me tomorrow when I'll be back with another new problem. Thanks for